When it comes to building web applications in .NET, there are tons of different packages that we can use, and one of the most popular ones is Entity Framework Core. But I often stick to a couple of other packages that replace this. Hi, my name's Nick Cosentino, and I'm a Principal Software Engineering Manager at Microsoft. In previous videos, I've talked about using Dapper, I've talked about using DbUp, and in this video, I want to walk you through building a very simple web application in .NET using both of those things instead of Entity Framework Core. Now, the goal of this video is not to say that Entity Framework Core sucks or anything like that, and in fact, I think it's actually a very awesome package to be able to use. I think it solves a ton of needs for most people. If I'm being honest, it's probably just because I don't spend enough time with it, and that's because I haven't carved out the time to go sit down and force myself to use it. But in this video, we're going to look at using Dapper and DbUp together in order to get some migrations in place for a web application. So if that sounds interesting, remember to subscribe to the channel and check out that pinned comment for my courses on Dome Train. And with that said, let's jump over to Visual Studio and jump into everyone's favorite sample application, the weather app. Alright, so on my screen right now, I have a bit more code than what comes with the traditional weather application, but you can see that I do still have this weather forecast route, and I'm going to walk you through the different pieces that we're going to need to build this application. So to start off, I want to jump into the NuGet packages, so I'm going to go over to the project itself. You'll see that I have Dapper referenced here. I am going to be using SQLite with both Dapper and DbUp, so you'll notice that I have these two DbUp packages, the core one, and the SQLite one as well. And then I also have Microsoft Data SQLite. You can follow along with this entire video and you can pick something that's different than SQLite if you don't want to use SQLite. In fact, in most production environments, you're probably not using SQLite unless you're building a mobile app or something like that. I'm just doing this for speed of development to put this video together, but you can absolutely swap out the different pieces here for Postgres, MySQL, SQL Server, anything you want. So just a heads up, that's why I'm using these particular packages. You're going to need a set like this, and again, you can pick a different database implementation, and just remember that you pick the alternative DbUp package for that as well. Once we have these in place, I'm going to walk through the structure of this application and talk about the different pieces that we're going to need to get this going. So, of course, we're going to need our minimal API, and I'm going to come back to the details about what's going on here because it's a little bit different than the one that comes with the sample app, but the concept, the core idea of what it's going to do are very much the same. It's just that we're going to be loading that data from a database instead. What I want to start off with is a DbUp migrator background service. And you can do this in many different ways. And I want to touch on this for a moment because I think this came up in comments, whether it was on YouTube or LinkedIn where I was posting information about DbUp. Some people were saying, well, hey, if you're going to be doing database migrations on app startup, like, isn't that going to be a problem if you're doing microservices and things like that? And the answer is absolutely yes. You can't just blindly say, okay, I'm going to do on every startup of every web service, I'm going to try to go migrate the database. You can totally get away with this kind of thing if you have a monolith, if you have things controlled, but the idea is that you need to think about where these things and when these things are going to run. So when I put together videos like this, my goal is not to say, hey, just copy and paste this code and you have a working application. I'm trying to give you different pieces to play with, and it's still going to require a bit of homework on your end to go do the right thing in your circumstances. In this video, we're going to look at having a background service that does migrations on startup. That means that you're probably not going to want to use the exact same thing in your application if you have different instances of this thing. If your migrations are going to be such that if you have an intermediate step or you don't have an intermediate step in the migration, what's going to happen to the other services that don't know how to read from the database in that current state. So you have to think about all of these things. And this is another reason why people generally say, hey, look, if you don't need microservices, don't do it. Start with a monolith, start with something that's a lot more easy to control the deployments for. There's lots of complexity that comes with multiple instances. So in this case, this is going to be a monolithic application. It's very tiny, it's a single endpoint. And we are going to have one instance of the database, one instance of the service. So when I go to make this background service, it is going to, on every app start, try to migrate the database if it needs it. And like I said, if that's not going to work in your case, you're going to want to think about when and how to do those migrations. So I just want to call that out. So you'll notice I have this public sealed class DbUp migrator from line 61 down to 77, and I'm going to walk through what that does. So to start off, it's going to take in a DB configuration. We're going to jump over to this in just a moment. And what you'll notice is if you've watched the previous videos on DbUp that I put together, this is very much the same idea. We're going to get an upgrader, and we need to build that upgrader. So we're going to be using SQLite, like I said. So I'll read in the connection string off our DB configuration. We'll jump over to that shortly. We are going to run the scripts that we have embedded in our assembly. There's different ways to do this, but we are going to have migration scripts that are embedded in the assembly. So this line here on line 71 is going to load that for us. Log to console is, as you might guess, just going to log some information on the console as it's doing the upgrade, and then we go build that upgrader. Line 75 is just going to perform that upgrade for us, and once this whole thing finishes running, we should have a database that's in a working state for our application. So all of the migrations should have finished, and we should be good to go use it. That's going to be the background service, and just to show you, if I scroll all the way back up to the top, you can see that I'm adding a hosted service called DbUp Migrator right on to the service collection. Doing it this way means that ASP .NET Core is going to start up this service for us. We don't have to do anything else. It will just go run it on startup. That means that we get migration on startup. I wanted to jump over to this DB config. So let's go jump into that so we can see it's going to be a couple layers of things going on here. The idea with this DB configuration is that I just wanted a sort of a simplified encapsulation of the settings that we have in the app settings. So you'll notice I'm taking into this primary constructor an I configuration, which is going to be coming from app settings. From there, I'm looking for a section called connection strings, and then I'm getting connection strings, which if you look a little bit above on line 79 to 80, this is just going to be a record, so a data transfer object that has the different properties that we're interested in that map to the app settings. What I do is I get that, so if you look at what I've highlighted from 85 to 87, once we've executed this part, we now have an instance of this connection strings record, and then we can pull off the default connection property. And of course, what I'm doing is just to be a little bit more safe, is that if that doesn't exist, I'm explicitly throwing an exception instead of allowing like a null or something else to kind of propagate through the system. And in fact, what could be even better is having a little bit more specific checks around this. So maybe if this is only checking if that's null, so maybe if we wanted to have null or white space, we could do a better check here to throw an exception on app startup. In my opinion, and you can do this in many different ways, in my opinion, crashing at the start of the app if you're not configured properly is good practice. You might have different considerations where you don't want that, but if this is misconfigured, the rest of our current application, this weather app, it just won't work. So there's no point in going further if we're misconfigured. Before we continue on, this is just a quick reminder that I do have courses available on DomeTrain. If you're just getting started in your programming journey and you want to learn C#, you can head over to DomeTrain. I have a Getting Started in C# course. It's approximately 5 hours of content taking you from absolutely no experience to being able to program in C#. And after that, I have my deep dive course, which will take you to the next level with another 6 hours of content so that you can start building basic applications. Head over to DomeTrain and check it out. Let's head back to the video. Just to show you what this looks like, right? So we see connection strings, we see default connection. If I jump over to app settings, you can see that I have connection strings here, and then within that I have default connection. Here on the right-hand side, we have the connection string that we're going to be using for SQLite. If you're not familiar with SQLite connection strings, this is a super simple one. It just says where the file is, right? So it's going to be called weather.db, no special relative path, no other settings going on here. Just super simple. If you're using a server for being able to do this, you might have login information and the host and the port and that kind of stuff. But SQLite in this case is going to be very simple. From line 9 to 11, this part of the config is all that we were reading in back over in this part of the code. So this part right here is just going to be some code that maps to our app settings so we can go leverage it in the rest of our application. At this point, we've seen loading in some of the configuration, and there's many ways to do this. This is just one way. We've seen that we have this DbUp Migrator background service. Again, many ways that you can do this, and I do strongly suggest that you consider how this would work in your application, especially if you have multiple instances of the database, multiple instances of your service running. You need to think this through. This one is very simple, of course. Let's go to more interesting parts. I actually don't need this part here. So let me get rid of that. That's just left over from the sample app. I want to talk about this route, and then we're going to start running some code to go see how this works. So this route is just the weather forecast route that's built in the sample app, just modified it a little bit. So I'm going to be passing in the db config. I should have mentioned that this is registered onto our dependency injection container, so we can pull that in on the minimal API. I'm also taking in a cancellation token, and I forgot that probably needs to be passed in on here, so we'll go update that in just a moment. In order to go perform this forecast, what I wanted to do is say, let's start from the time that someone executes this and go 7 days out. Maybe you want to have query parameters that give you a date range. I'm just trying to keep it simple for the demo. What we're doing here is right on the minimal API, we're going to open up a connection to the database. So that's line 27 and 28 here. And then we're going to use Dapper in order to be able to pull this information back. I like Dapper personally because I do like using SQL. I like writing the SQL out myself. I like seeing it. I like being able to work with it. If you don't want to look at it, you don't want to deal with it, Entity Framework Core can absolutely be an option for you. Like I said, I'm not trying to say it's bad. And of course, I think newer versions of Entity Framework Core do allow you to go write your own SQL inside them if you need to. So you might say, well, Nick, why aren't you using Entity Framework Core? And it's just because I'm comfortable with this for now. I will eventually move over to EF Core, but that's not what this video is about. This syntax is going to be for SQLite. So most SQL is compatible across different databases, but you do need to consider, like, if you're like, hey, I want to follow this tutorial, but I'm picking a different database implementation, just make sure you're paying attention to nuances with different variations in how SQL is interpreted for those databases. This is pretty basic, so nothing too fancy here. This part is how we use parameters in Dapper. So you can say I have start time and end time, and then you can see right here on line 37, they're also being used. Now, I did mention this cancellation token is up here, so I want to change this a little bit, and I'm pretty sure I need to do a new command definition, and inside of that, very much the same. I just need to say cancellation token, cancellation token. If you are familiar with using cancellation tokens in your routes, and you should be, you are able to cancel an HTTP request, and that means that we can cancel all the downstream work and free up server resources if we need to. This one's going to go pretty fast. It's not going to be a big deal, but in my opinion, this is a best practice to be able to pass your cancellation token down right from your minimal API through the rest of the app. If we look at what this is doing, it's going to go run this SQL. I probably would do a little bit better of a job, not use star here. I'm not totally against using a star for selects, but I have found that Dapper can be kind of picky. So if you modify the schema and you have a star there, you might not realize that you have something going on and it might break. And maybe that's what you want. Maybe you want to say, hey, look, I've modified this schema. I want to force anyone selecting from this table to go update all of their calls. Maybe you want that. In my opinion, usually I don't. Not when using Dapper, at least. There are cases where I will use select star, so I'm not saying it's necessarily bad, just something to think through. But if I select these explicitly, I just want to show you that ID, date time UTC, and temperature C, if we go down all the way to this weather DTO, you can see that I have the same things mapped here. If we pause and look at this for just a moment, you might say, something looks weird about this. Maybe a couple things look weird about this. And you're right. The first one's going to be date time UTC as a string. This is just a SQLite thing. In SQLite, they don't have a date time as a type, so that's kind of weird. You can use a number for that and do sort of like milliseconds or seconds from the Unix epoch. That's totally fine. You can use strings. I'm just using strings to make it readable for this demo, but SQLite's kind of weird for this. Dapper doesn't have a problem with using a date time here. It's just that SQLite doesn't support it. So when I'm doing this and building a record to map with Dapper, it needs to have a compatible type. I'm pretty sure with Dapper you can use custom mappers and do things like that. I'm just doing this to be very simple. I just wanted to call out why you see it this way, because we'll see it come up in just a moment again. I have these three things that map to the different columns that I'm going to have in our database. And we haven't looked at the migrations for that yet, but we will once we start to go run it. So going all the way back up here, this part is going to select in that date range. I'm going to pick those three columns that we were just talking about, and then you can see query async with this weather DTO Dapper is going to do that mapping for us, and we will have weather DTOs to work with. Now, when I go to do the return, this is something that I like to do personally. I don't like to have my data transfer objects sort of bleed between different parts of my application. Generally, I would go build an entire repository class for this type of thing. It feels like overkill, especially for this demo, but just to call it out, this code that I've highlighted from 27 to 46, I personally would generally pull into a repository. That way I can have my sort of SQL related things in one spot. I might have an abstraction with an interface on that repository as well. The way I like to design things, but in this case I'm not doing that. It's all directly in the minimal API. What I mean by this part down here where you see I'm doing a select and then newing up an object is that I don't want to have things that are implementation details for my backend, like specifically how I'm querying records for my database. I don't want to have that bleed all the way through to the route, so the caller doesn't have to know details that they shouldn't have to see. So one example, if you pay close attention on here where I'm newing up this object, you'll notice I'm not providing the ID back. I don't think that the caller of my API that's just trying to get a weather forecast needs any idea about the ID, like the row ID in particular, of my SQL records. They just don't need that. Now, you might be building other systems where you want that kind of thing. You need an ID for a user and you're like, yep, we need to pass that back to the caller. Absolutely. But in my opinion, I like making an explicit decision about that. And this is where I wanted to bring up the date time thing once again. So I wanted to show you on line 50, I had this thing commented out. And that's because when I was putting this example together, I totally forgot that SQLite does not have date times. So my object, my record, had datetime UTC as a date time. And what I wanted to do is on my JSON that's being returned to the caller is format that in a way that I was happy with. So line 50 was the example that I was going to show you where we took a datetime object and then I could explicitly format that the way that I wanted it to be shown in the JSON. We don't have that. So I had to comment it out, and I'm just passing a string back here with no different changing in the formatting or anything like that. But I am removing the ID. I'm not passing the row ID, or in this case, my explicit ID, back to the caller. So hopefully that's pretty straightforward. I just wanted to show you that I am using Dapper to get records out of the database, and then before I return them back to the caller, I am doing my own transform on them to make them in the format that I want my caller to be able to see. So far, so good. Now it's probably time to go run this thing. And just to recap, we are going to run this DB migration part at the beginning. And then my initial application URL that we're going to hit is weather forecast. So when I start this thing up, it's going to go hit this route. Let's try it out. And the first thing that happens when we go to run this thing is that it fails. It says there's no such table weather forecast. And you can see in the URL bar here, it says weather forecast, like we are hitting that route and it's failing. So what's going on? Why is this happening? Didn't we go set everything up properly? And the answer is sort of, but I left out something on purpose to be able to start walking through these different steps. So we have all the right code, at least in my opinion, this is functioning, working code, but we did not include the scripts for migration. So this code down here that's running and doing the migration with DbUp, it's trying to go look for scripts in the assembly, and you can see I have this folder on the left here where there are scripts to go run, but I didn't go embed them. So if I click script 0001, this is the one that goes and creates my weather forecast table. If we look in the top right, I need to set the build action to be embedded resource, so I'll go do that now. And if I save that, now at this point in time, if I go run this, we should have a weather forecast table created. So let's go run that now. Okay, and now that we've run that, you can see that, well, it's not crashing, but it's also not that exciting. And that's because there's nothing in here. So at least at this point, DbUp did the migration. That's cool. That all worked. To prove to you that that's the case, you can see that it's doing the database upgrade. We go upgrade the whole thing, right? So it actually says which script it ran. Then we start running our server. This all worked. It made the database. And then Dapper also worked accordingly as well. So it went and queried that table, but it's a brand new table. There's nothing in there. So this is just telling us that we're moving in the right direction. There were no results. So far, so good. It's just not exciting yet. So how can we make it a little bit more exciting? Let's go add in another migration. This is kind of silly, right? Because I'm just using a migration to go populate data, but this could be a real scenario. You might have data that you need to ingest or import into your product. Maybe you want to go run a migration like this that goes and seeds some data. I'm not telling you this is right or wrong, and this data is totally made up, so, it doesn't really matter in this case. I just wanted to give you an example of how to go run an additional migration. You can see that I've called it script, and then this one is 0002. So if I go embed this one now, make it an embedded resource and save it, now at this point, DbUp has already done the migration on the database for the first script, but this second script is a new one. It has not yet migrated that. So if I go and press play, it should go now migrate this part. And if I bring this part up, let's see, beginning database upgrade, right? Now it's saying executing database server script right here for 0002. So that's cool. The upgrade was successful. And if we check it out, we do get results coming back. So this is going to be the records that are from basically now in the next 7 days out, according to that last migration with that fake data. And just to prove what's going on here, if we take this first record, right, you'll see that this doesn't have the ID. It's not taking that direct record from the database. It's actually doing that transformation. So this is part of what I was showing you, especially if we look at this part right here, right? It's not including the ID. Just to do one more example here, just to kind of put it all together, I'm going to go ahead and delete the database, right? So we'll get rid of it. Now we're going to run both migrations together because I did them incrementally, but this is going to be totally from scratch. There is no database. We're going to create the table with one migration, seed it with the next one, and then run this Dapper query. Let's try it. And if we have a look here at the migration part, we can see that it's doing script 0001 and then 0002. So great, that part worked. And if I bring over the weather application, we can see that we get all the results in the JSON. So this is an example of it working end-to-end, migrating two tables. And that's just a quick example of how you can use DbUp and Dapper together to do database migrations and query records from your database. In this example, I did use SQLite. It's got some weird characteristics like not having a built-in date time type. That's okay though, you can take these same concepts and apply them to different database types. So I hope that you found that useful, and I wish you luck trying out Dapper and DbUp in your applications. Thanks, and I'll see you next time.